Welcome to the new session. In this new session, we are going to know about the nanomaterial synthesis and processing. Until now, we have understood about the introduction of nanomaterials, importance of nanotechnology, emergence of nanotechnology, both bottom-up and top-up approaches in nanotechnologies and challenges in nanotechnology. Now we are going into the next part, that is nanomaterials synthesis and processing. Under this we are going to know more about methods of creating nanostructures by different processes like ultrafine powder method, which includes mechanical grinding. Then we will know about wet chemical synthesis of nanomaterials by solgel process, gas phase synthesis of nanomaterials, then flame assisted ultrasonic spray pyrolysis. Later we will know about gas condensation process, that is GPC, and then we will look into what is chemical vapor condensations. So these are the things which are to be known under nanomaterial synthesis and processing. Next, going into detail about nanomaterials synthesis and processing, let's give some highlights why we require this nanomaterial synthesis or nano production. What is the need of having these methods for creating nanostructures? As we know that nanomaterials and nanoparticles are used in broader spectrum of application, which we have seen in the application or emergence of nanotechnology. So there are many products which are used in technology which are at a nanoscales or nano level, and most of these nano products produced are on an industrial scale, and these although have some advantages, there arises some disadvantages, or there are some byproducts in the manufacturing of these materials. Most applications here mainly require them to be precisely defined, or their scale or a range of them of these particles has to be decisive, and these particles should be of a monodisperity. Okay, so these are the key points with which we are going to put our highlights of why nano production is required. When we think about the production of nanoparticles, the two basic strategies which come into our mind are the top down and the bottom up approach. So more highlight will be on how these approaches are going to be created. So here when we tell that it is a top down, so it refers to the mechanical crushing of a source material using various mill process like a ball mill process, or we use any of the mechanical synthesis process. Then bottom up strategy, here it tells about building a structures by a chemical process. So you are building atom by atom, molecule by molecule, and you are coming up with nanomaterials. So this is how the approaches are being set or defined for nanoparticles. So here is one of the picture which is going to give the outline how these nanotechnologies or these processes are used at a different level. So you can see on the left side, that is the top-down approach. So here in the top-down approach, we can see there are different technology right from the micro technology, that is nanolithography and milling process, and we are having the thin film technologies, lithography and imprints, which are going to bring the materials from different levels to the atomic level. So this is called as a top-down approach, means from a macro level, macroscopic level, so it is going to go into the microscopic level, that is the atomic level. So here another method of approach which is been used in nanomaterial production is the bottom up. So as we see at the bottom level, we are working on the atomic level. So from the atomic level, the nanoparticles are being built and they are being organized in such a manner that they are going to be approaching to a nano levels. So examples of these ones are the aerosol, solgel, precipitation process, and we see here they are self-organization. There is a self-organization happening, that is supramolecular structures are going to develop. So this is called as the bottom-up approach. So in largely we can tell that there are two parallel approach which are going in building these nanoparticles or nanostructures. Both are equally contributors for production of these nanomaterials or nanoparticles. Okay. Let's know one by one in detail the two approaches. Firstly, we'll understand about the top-down approach, or we call it as a mechanical physical production process. So as the name itself only tells, it is a top-down, where we are going to take the help of a mechanical physical theory, and here the application of force and pressure are going to remove, or it is going to make the particles into a powder or a nano levels. So this is mainly used in our powder technology also. So this is the traditional way of producing nanoparticles. So here the crushing of the materials will be taking place. Here we include different crushing methods. Mainly here we use the milling technology for producing the nanoparticles. So how it will be looking? So you can see there in the figure 2, that is the steel balls which are going to be used as a milling tool. So in between these two balls, the crushing of the materials will be taking place. So mainly these particles are going to be having the shearing or compression action on this one, and they are going to get into smaller levels. So basically we can see here the mechanical physical process happens to be a mill which is going to be going from the basic material, that is bulk material, is going to be going into the coarsely grinded materials to a bottom down sizes, and then when you are multiply feeding these materials into the mill, so what we get the fine grinded particles. This mainly is used in our powder technology also, where we are going to have the production of nano level powders. So the milling production approach uses mill to crush microparticles. This approach is applied in producing metallic and ceramic nanoparticles. So as I have told you, these are mainly used in our powder technology for creating nano powders. These mills are equipped with a grinding media. So here we can see in the previous figure there are the different grinding medias where they are going to be applied with the forces. So here the grinding media is composed of a carbide tip, or they are case hardened steel. So the steel balls are going to be rotated. These steel balls rotate around a horizontal axis. These are working in a inert gas medium, so that these particles don't get oxidized, or they are going to be free from contamination. The balls rotate with a high energy, inside the container and then fall into the bottom container because of its self gravity. And here crushing happens because of the kinetic force which is induced, hence because of the rotation of the ball mills. And these solid particles which are going to be created are of nanocrystalline in nature. And milling involves both here thermal stresses and it is highly energy intensive work. So a high amount of energy is getting liberated during this crushing of these materials. Here we can see the phenomena in a milling process. So this is the planetary ball mills. So you can see the steel ball, these are the steel balls and the materials which are being put into this vessel. So you can see the different grades of the steel balls. Here in this figure you can see the different grades of steel balls for having the milling operation. These steel balls are made to roll with the help of rollers. So these steel balls are going to be placed in this way with in the container, and they are being placed into this rotary element. The rotor is going to rotate and the nanoparticles are going to be getting crushed. The phenomena of crushing here, so here the nanoparticles are going to be created because of the elastic deformation. When these coarse materials come in between the steel balls because of the action of a kinetic force, what will happen, the material gets deformed. Initially they will be going into a elastic deformation, then after that they ends are promoted into a plastic deformation. Shearing of the material will be taking place and we get at the end fractured amorphized chemical reactions on this one, and we get the nanoparticles. These are the nanoparticles which are going to be created after from the bulk material. So this is how the planetary ball mill is going to work, or a milling process is. So this is a small compact machine made to rotate at 15,000 rpm. So this is how the milling process takes place. The next method of producing nanoparticles using top-down approach is the laser ablation synthesis. So as we know that laser beam can be used for preparing the plasma or higher energy intensity focused beam. So this laser beam can be used for evaporating these target material. Mainly what will happen, this target material, so this target material like we are having the gold plate or the silver plate or platinum plate. So if you want to convert these plate bulk materials into a nanoparticles, so we go for this laser ablation techniques. So in this technique we generate the nanoparticles using this powerful laser beam. So this powerful laser beam is tilted with the help of this mirror, so it will be reflected from the mirror and it will be targeted to the target material. So here the target material will be something like gold, silver or platinum, and it can be also increased, or this method can be also been taken into preparing some metal alloys. So that is one of the unique advantage of this method. So how this happens? So here very high laser energy is focused on the target in the solvent. So this is the solvent here, this is the solvent, and the laser delivers short pulses of energy. So these will be delivering, so it will be a laser beam here will be in the form of a wave, so it will be delivering short pulses of energy. So this energy will be quite enough to vaporize because of this plasma or plasma pulp. What will happen, heat is going to be generated, and here what will happen, the target material is going to vaporize, and small parts of metal targets which will condense. So So these metal particles will be getting condensed and they will be condensing in the solvent. By using this method, we can generate different noble metallic nanoparticle. Noble means the materials or metallic particles which don't react, so they are non-reactive. So these type of nanoparticles which are to be generated or to be prepared, for that we use this technique, laser ablation. But the main requirement for this one is we have to be having a high laser beam, which is one of the costliest affair, and this has to be done in a inert gas atmosphere and without contamination, and maintaining that inert gas atmosphere without contamination, again we require a set of equipments. That is again one costly affair, where a vacuum pump or a vacuum creation zone has to be generated, and here basically this is done for preparing the nanoparticles in a solvent. So again we have to filter these nanoparticles from these solvent. That is one of the limitations of this laser ablation techniques. So quite good, it is a unique technique where we can see that it can seamlessly produce, means continuously it can produce. That is one of the advantage of this technique for different metal alloys also. Next, the third method which we are going to discuss in producing nanoparticles by using the top-down approach is the arc discharge synthesis. So under this arc discharge synthesis, here we can see a setup. Here we see that the arc is developed from the in between, the gap between the cathode and anode. So here when this arc is developed, so a localized temperature is going to be created, and because of this localized temperature, which is of a higher degree, thousands of degrees of Celsius, so what will happen, it will effectively vaporize the target material. So this vaporized material gets condensed into the solvent and makes the nanoparticles. So this arc discharge method can be taken into production from bulk materials. So bulk materials can be brought down or broken down into small nano level particles. In this particular case, we can see the setup. It requires a cathode and one more the anode, and when these two terminals are brought in close vicinity, that is they are kept very close, that is kept in this proximity to each other, what will happen, the applied voltage, so the high applied voltage from the anode tries to jump towards the cathode. So this jumping of the electrons from anode to cathode in the process is going to create an arc. Due to this higher potential difference, the arc is going to be generated, and the arc which is generated is going to produce ongoing thermal plasma discharge. So it is going to be having a high temperature. So as I have told you, what will happen, the local temperature around this plasma around this arc is going to go to several degrees centigrade. So when it goes to several degrees centigrade, what will happen, the target material which is here, it is going to get vaporized. So the vaporized target material is going to be getting condensed. So here the temperature is very high. When it comes to the surface or away from the target material, what will happen, these are going to get condensed and they create nanoparticles. And most of these metallic nanoparticles are metal oxide nanoparticles used in this one. Here you can see a setup of arc discharge synthesis apparatus mainly used for CNT production, that is carbon nanotubes. So carbon nanotubes are mainly produced using this method. This method is also can be done in a case in chemical laboratories also at a very limited cost. Only thing what you have to requirement here is the high electric supply, or to create a potential difference, so that the arc is going to be generated between the anode and cathode, which can be done with the help of transformers. So easy technique, method is simple, mainly used for metal oxide nanoparticles. Okay. Next, after knowing the top down approach, now we'll focus on bottom up approach. So bottom up approach, in this case we see the chemical-physical production process. Here in bottom up approach, this method is basically based on the physicochemical principles of moleculars or atomic molecules, which are going to get self-organized. In this one, the atomic molecules are made to place in a particular network or an order, so that they form into a nanoparticles, and then they can be used as crystals, or when they happen to go at a higher growth, we can get agglomerated crystals also. This approach produces selectively a more complex structures from the atoms, which are having their unique properties, and with a better controllable size we can give a definite shape, and it can be done at a given specific range also. Moreover, here we are having two methods in a bottom up approach. Those are the liquid phase and the gaseous phase. So in the gaseous phase, we are having the aerosol process, that is flame hydrolysis or spray hydrolysis. So here we are going to convert the precursor, that is the primary content or the making of the sized nanoparticles into a gaseous phase, then condense, and then we are going to create a film or a coating of the nanoparticles. Next, one more is the liquid phase. Here we happen to see that it is mainly production of nanomaterials in a wet state by using precipitation process, solgel process, or a hydrothermal process. Out of this, we are going to discuss moreover on the wet method, or we call it as a wet chemical solgel process. So in detail about this process we are going to know now. So as we have known that in bottom up approach there are two methods, that is the liquid phase method and the gaseous phase method. Under the liquid phase we are having the wet chemical synthesis of nanomaterials, that is the solgel process. So material processing by solgel was mainly introduced, and it was very well known in 1800s itself only. There are varieties of techniques and rediscovery happening in this technique. Mainly this is used at a laboratory level for preparation of nanomaterials in a wet state. So this is been happening since the 1970s, when we can see that the glass were produced without melting the silica. So without using high temperature, the glasses were produced. So solgel or solgel technique of preparing ceramics and glasses are very familiar. These are used in thin films, preparation of fibers, and preparation of dry amorphous powders of ceramic or glass material. Here solve is a collider. So here we see that the dispersed phase is so small that a gravitational force does not exist in this particular medium. Only here the contact is because of the van der Waals forces or the surface charges which is present in these molecules. So a molecular suspension of solid particles of ions will be happening in a solvent. Next, we convert this into a gel form. Mainly this gel is a semi-rigid mass that forms when the solvent of the solve begins to evaporate. Means here we are going to exhibit this solve into a condensation process where we are evaporating the water content, and this begins to drying up and the particles or the ions will be left behind, which are going to join together and they are going to form the networks. Hence it is called as a gel. So it is called as a continuous network. Sol means solution, the shortcut of a solution, and gel is the network, the formation of network. Now let's know how a solgel process or a working of a solgel process. So solgel process is basically a preparatory method which has been used in preparing synthetic or nanoparticle preparation with this synthetic material. Solgel is also called as a wet chemical technique because all this process happens in wet state. So the chemical process or the synthesis process will be happening in presence of moisture. So hence it is called as a wet chemical technique. Here it uses either a chemical solution, that is called as a sol, a shortcut of solution, or a colloidal particle, means a solution of nanoscale particles, mainly to produce an integrated network or a gel, that is the solve gel component. Here for preparation of this one we require the main important part, that is main important material, that is called as a precursors. The precursors are used in making these nano-sized materials in a metal alcohol oxide. So metal alcohol oxide are the typical precursors which are used. Why it is called a alcohol oxide means here the metals are going to be dissolved in water where they are going to get oxidized or their hydrolysis will be taken. But these metals will not get diluted into this water so easily. So hence first we are going to mix it with the alcohol. So hence we get these metal formation. Metal oxide involves containing metals having oxygen, so it will be formation of metal oxide metal. So oxy metal form. So this bridge formation is going to happen. So in the starting, metals will undergo reaction with alcohol alcohol, it will be getting reacted and metal gets dissolved into water when it is added. So here the metal oxides are going to be dissolved in water and this water acts as a catalyst, but it doesn't dissolve into water so easily. So hence we require to make it get soluble by using alcohol, that is metal alkoxide. It is added with water. Metal oxides, alkoxides are homogeneous solutions. These are homogeneous solutions. So it is completely dissolved into water, but it needs to be continuously stirred. So stirring is required. So hence this has to be homogeneous. So for that reason we make it to go under this process, that is hydrolysis, and then later it is going to be condensed or dried, so to form a solution or a gel, formation of solution to create into gel, that is what we call it as a polycondensation, which leads to formation of colloids. These colloidal systems are composed of both a solid particle dispersed in a solvent containing sizes of 1 nanometer to 1 mm. The solution is then involved into forming inorganic network called as a liquid phase, that is gel. So here the metal oxides involves in connecting metal centers with the oxygen, so it is a formation of MOM or hydroxy bridges, therefore generating metal oxy or metal hydroxy polymers in the solution. This solution has to be undergoing proper distribution, so for that aging has to take place, means it has to be dried. So a drying process of this one will be taking place. The liquid phase is removed from the gel. In this drying, evaporation will be taking place. The water is going to get evaporated. As we are aging from a long period of time, so for a couple of weeks when we are going to keep it, so what will happen? Due to aging, the water molecules in that it will get evaporated, leaving out the formation of gel. Then we want it into a form of a amorphous powder. Then what we have to do? We have to further heat it or subject it to higher temperature. So thermal treating, that we call it as calcinations, is performed in order to favor further polycondensation and enhance mechanical properties. So we can see this solgel process here. So the precursor which is the initial part, that is preparation of synthetic nanomaterials, is going to be taken here, and it will be, for example, silicon and it will be alcohol, both are added into this one, and it is going to be added with the alcohol, water also. It will be H2O is also added here, H2O is also getting added, and it is continuously stirred. Stirring is taking place. This process is called as a hydrolysis. So hydrolysis, it should be continuously stirred. It will react with water and it will be completely getting soluble or dissolved. So this is called as a hydroxide. So metal oxides, alkoxides are going to react with water. Here water is going to act as a catalyst. Then after formation of the solve is made to condense. So here there we are going to condense. So during this condensation we see the solve is going to get distributed, arranging, and here it is going to form into a gel. The gel formation is taking place. So here water is getting evaporated, so water goes out, so it will be a metal and oxy metal formation, that is silicon and silicon. So this is formed. Then to get the liquid removed, that is encapsulated liquid can be removed by the gel by either evaporating drying or with a supercritical drying tip. So evaporating drying means drying at 100 degrees centigrade. So you are making the solve gel formation by evaporating it by 100 degrees centigrade. So this dried gels which are going to get evaporated here, it is called as a extrogel. So these are the extrogel. The dried product is extrogel. Then when you are going to take the same process, the drying process, but you are going to heat it above 100 degrees centigrade. So that we call it as a supercritical drying. So the dried gel is called as a aerogels. So these are the aerogels. Why we require this extrogel and aerogels? So extrogels will be the final compound, but they are not into the purest form. So if you want the nanoparticles in its purest form with the highest porosity, then in a pure volume, then what we have to do? We have to subject this one to a supercritical drying temperatures. So that is above 100 degrees centigrade. Then what we get? We get the final compound in a pure form. So this is a typical process of preparing nanoparticles using solgel method. Now, after knowing the wet chemical synthesis process, that is solgel technique, now we'll know some of the advantages of this solgel technique. Mainly we can see that this solgel technique can be used for producing thin bond coating. So in the process we have seen that they get deposited onto the substrate. So they are having an excellent adhesion between the metallic substrate and the top coat. So because of this unique property, what we get, we are able to create some thin bond coating, and they can produce thick coating to provide corrosion protective performance. So using this technique we can see some glaze also in glazing of the glasses. We can see this technique also used for anti-reflective type of glazing glasses. So ultraviolet rays protective glasses, there we see this type of a technique which can provide coating and they are helping. So like that, for corrosion resistance also this technique can be used, and can easily shape the material into complex geometries in a gel state, and it can have a low temperature sintering capabilities as low as 200 to 600 degrees centigrade. At these temperatures also it gets sintered and it is going to get grain structure uniformity. So that is one of the unique nature of this one. Can provide a simple, economic and effective method to produce a high quality coating. I've told you this coating can be used in different types of glaze or glass glazing or anti-reflective coatings, or in case of corrosion resistant coating, and this method can be used for at a simple method. So where it can be used, how it is getting its application in detail we'll know. So it can be used in a ceramic manufacturing process, as an investment casting material, or as a means of producing very thin films for metal oxides for various purpose. And other elements like metal oxide can be easily incorporated into the final product, and the silicate sol formed by this method is very stable. So where we require metal and metal oxide type of products which is going to be having these type of coating, there we can go with the solgel. So other products fabricated in this includes ceramic membranes for microfiltration and ultrafiltration and nanofiltration and evaporation and reverse osmosis. Mainly this application we see it in case of preparation of filter materials in dialysis, and in case of water filters, and in case of our sewage treatment, where we have to do the filtrations of these chemicals and separate, and mainly in case of refineries, where different levels of filtration has to happen for these refinery oils. For there also this technique can be used. Okay, thank you. You can contact me at my email id, that is naveen.kalal @canaraengineering.in.